Welcome back to this section of the course. Let's look at some examples involving arithmetic sequences. Just to summarize how to find the nth term in an arithmetic sequence, let's write out what the terms would be. The first term we usually denote by a, then the next term would have one common difference added to it. So the second term would be a plus d, and the next term would be one additional d added to it. So a plus one more d will make it a plus 2d, and so on. So the fourth term will be having a plus 3d. And the nth term in general, what would it be? How many d's do you think you will have in the nth term? Nth term is just saying the position, where the position would be a number n. So as you see, the fourth term has three differences. The third term has only two differences, because we made only one jump to get to the second term. We made two jumps to get to the third term. We made three jumps to get to the fourth term. So that means that we have only one less jump than the position itself. Therefore, we write a plus n minus 1 multiplied by d. I hope you remember this formula well, because we usually denote the formula by u with subscript n, and we say that that's equals to this expression here. Now, of course, you can expand the bracket and use it with numbers given to you. Let's see an example how to use it. So, here we have a common difference of 14, because when you subtract 20 from 20 and 6, you get 14. We have been asked to find the nth term. So we say a is what? A is a 6 here, because the first term is a 6, and the common difference is 20 minus 6, which is 14. You could also subtract any other two terms. You could have said 62 minus 48, and you would have got 14. Now, we said the nth term has this formula. This formula is not in your formula booklet, so you better memorize it. So we're going to put 6 there and d there, the value of 6 and 14 into this equation will help us to calculate and simplify it. So just multiply out the bracket, you'll get 14n, and when you combine minus 14 and 6 together, what you end up with is plus 8, minus 8. So this is called the nth term. How is it useful? Well, we use it in the next part of the question to answer, to find what's the first term that will exceed 20. The term that would exceed 200, so 200 would have to be bigger than this formula. When we solve it, we actually find the position first. So if we solve this inequality for n, the n will tell us what position it will be, and then we can substitute it actually, and we can confirm that what's the first term that would exceed 200. Sorry, I have made a small error here. We better write this inequality right way. So it should be this way, because exceeding 200 means being bigger than 200. So let's solve it. So when you add 8 to both sides, you get this expression, and you divide by 14. Now, the first number bigger than 14.8 will be 15. So the 15th term would be the first number over 200. If you actually do substitute 15 for value of n, what you notice is that 14 times 15 minus 8 is just slightly over 200. 14 times 15 210 and 8 will make it 218. Minus 8 will 202 actually. So this is just over 200, and that confirms that this is the first term over 200. Notice the n indicates the position or the index of a number. Another word for position in the sequence is index. Alright, so let's look at the next example. We have an arithmetic sequence that is decreasing. It's decreasing by value of 7. We've been asked to calculate the nth term, and we'll find the first term that would be negative. Let's calculate the nth term formula first. We say that a is 101 because the first term is 101, and then we find the common difference. It's simply minus 7. Then we'll substitute these two values into the formula on top left corner. The nth term will come out to be negative 7n plus 108. It might be simpler to write it like so. Now, to answer part B, we need to think carefully. The first negative number would be below 0. Therefore, we set this inequality and we say that it has to go below 0. So the nth term will tell us the position of the number that will go below 0. Why would it go below 0? Because the sequence is decreasing. So let's solve this inequality. Adding 7n to both sides, or subtracting 108 and dividing by negative 7. I hope you are careful here. If you do divide by a negative number, you do have to flip your inequality. Just be careful. Okay, so the first number would be 16th number. N is going to be 16th. Notice the th here. That's telling us that's the position of the number. So if you did have to find the actual number itself, you would say 108 minus 7 times 16. You can check. The answer is negative 4. That confirms that this is the first number that's below 0, because they're decreasing by 7. Okay, so let's look at the next example together. In the third example, we've been simply told the formula for this arithmetic sequence. U3 indicates the third number, and U8 indicates that it's the eighth number, that is 20. So we've been asked to calculate what A and B are, and then after that we can figure out the nth term formula. So what's the nth term formula for the third term? It would be A plus 2n. Sorry, my bad. 2d. Why would it be 2d? Because we have A plus n minus 1d, and n here is 3. So when n is 3, substituting that here would give us A plus 2d. And this we equate to 5. So this is one of our equations. The other equation, when n equals to 8, is A plus, again, 8 minus 1 d. So 8 minus 1 is 7. So A plus 7d equals to 20, because that's the eighth term. So un, or rather u, this is the formula for u8. Okay, so let's write it rather neater, like so. Then we have these two equations. We can solve them simultaneously. You can say 20 is bigger than 5, therefore I'm going to subtract equation 1 from equation 2. Subtracting 20 from 5 and so on. So when we subtract a minus a, the a's this cancel away, we get 15 here, and 7 minus 2d is 5d. So solving for d, we will have d equals to 3. You substitute it back in either equation to find a. A will be minus 1. So I hope you found these examples helpful. Just before we go, let's write un. Un is therefore minus 1 plus n minus 1 multiplied by 3. Multiplying that out, we get 3n minus 3 minus 1. So in the end, un is 3n minus 4. Okay, I hope you found this helpful. I'll see you in the next video.